This lesson, if the last lesson was adding rational numbers, you could probably guess that this lesson would be subtracting rational numbers. So remember, when we subtract rational numbers, basically, we follow all the rules that we've learned up until now. So it says to subtract rational numbers, use the same rules for signs as you used for integers. So remember, same sign, add and keep. Different sign, subtract, keep the sign of whichever number had the larger absolute value. And if you see these two minuses right next to each other, you turn those into a plus. In addition, you do have to remember your fraction rules and decimal rules that you learned probably in 4th grade. Okay, so this is a throwback to section 2.3, subtracting rational numbers, found on page 60 in your textbook if you're following along in your textbook, although you do not need to. In their first example, you can see they had a negative 4 1/7 minus a negative 6/7. Nice thing. Already common denominators. That'll pay off later. They turn the two minuses into a plus here, turning it into negative 4 1/7 plus 6/7, just taking those two minuses and making them a plus. And then they turned negative 4 1/7 into negative 29/7. 7 times 4 is 28, plus 1 is 29. So negative 29/7. Different signs now, so subtract, and you get negative 23/7, keeping the negative because the negative had the larger absolute value. Okay, so we're going to do a couple like that. And there are also decimal problems. If you'll remember decimals, same sign rules as integers. We do have to line up the decimals if that comes into play. So make sure that we're lining up the decimals is the big deal here. So we're going to look at these on your own problems. Number 1. We have 1/3 minus negative 1/3. And boy, do a lot of kids get this wrong at the beginning of the year because they just think that it'd be 0. But it's not 0. We take those two minuses, make them a big plus, and the problem is 1/3 plus 1/3. And we all know that that is 2/3. Keeping the common denominator. Don't add the 3's to get 6. You keep the denominator. Number 2. Negative 3 1/3 minus 5/6. Well, we have, let's go with finding a common denominator first. Before we do that, I guess we should turn this into just a fraction. So negative 3 1/3, 3 times 3 is 9, plus 1 is 10. So this would be negative 10 over 3 minus 5/6. So nothing too difficult yet. Now we need a common denominator. 6 works very well, which the nice thing is the 5/6 will stay 5/6. We'd have to multiply the 3 by 2 to get 6. So we multiply the top by 2, and we get negative 20. Okay. Negative 20, negative 5/6. Same sign. So we're going to add these to get negative 25 over 6. We added the numbers 20 and 5 to get 25, and we kept the sign. I got a negative here and a negative here, so I kept it negative. Because their problem started with a mixed number, they probably want us to turn this back into a mixed number. 6 goes into 25 4 times with 1 left over. And of course, it stays negative. Negative 4 1/6. For number 3, we have 4 1/2 for number 3 minus 5 1/4. Well, let's turn them into improper fractions. This would be 2 times 4 is 8 plus 1 is 9 over 2 minus 20 plus 1 is 21 over 4. We need a common denominator. 4 will work very well. That's nice because we can keep 21 over 4 just as 21 over 4. And we'll need to make this over 4. To turn 2 into 4, we multiply by 2. To turn 9, then we have, since we multiplied the bottom by 2, we multiply the top by 2, and we get 18. So now This is a positive. This is a negative. It takes the sign of whatever's in front of it. No sign is implied positive. Different sign, so I subtract the numbers. So I subtract 18 and 21, I get 3. 21 minus 18 is 3. The denominator stays the same, 3/4. But now I look back here, and my positive was 18, and my negative was 21. So this gets to be negative because there were more negatives, or because the negative had the larger absolute value. Number 4. Sliding into decimals now. I've got negative 8.4 minus 6.7. So both negatives. So I'm going to add and keep. Negative 8.4 and a negative 6.7. I lined up the decimals here. 11, bring the decimal down. 8, 6 is 14, plus 1 is 15. Add and keep. Negative 15 and 1/10. For number 5, I have negative 20.5, and this is going to be a plus because I've got a minus and a negative right next to each other. So negative 20.5 plus 20.5. So I have negative 20.5 plus 20.5. Different signs, so I subtract. 5 minus 5 is 0. Bring down the decimal. 0 minus 0 is 0. 2 minus 2 is 0. Hey, this is just 0. Oh, now I remember. We're adding opposites. And whenever we add opposites, we always get 0. So negative 20.5 plus positive 20.5, of course, gives me 0. Number 6. I have 41 hundredths here minus a negative 7 hundredths here. Well, minus a negative is plus, so this is really 0.41 plus 0.07. And we can add those easily enough. 8, 4, bring down the decimal. 0 plus 0 is 0. So 48 hundredths. Excellent.